Okay, welcome to Selective STEM with Selective class. We are going to discuss a very nice topic and just make for grade 9 to 12 students something for them to understand. Why do airplanes fly? Why do they fly? What enables them to fly? Something basic science in the field of STEM for them to know what happens. Shall we go? Let's go. Now, the objective of the lesson you are going to is about science that allows us to understand why heavy tons of airplane can travel across the world. What is the science behind it? Something very simple. What enables them to fly, to lift on the ground? So these are thought-provoking questions. Why do airplanes fly? If airplanes are extremely heavy, why don't they simply fall from the sky? Somebody will ask, yes, because if you throw an object, you throw to the sky, it comes back to the sky, it comes back. Why doesn't it stay? You want to see the knowledge behind it. Why do airplanes need a long runway and a high speed before they can take off? It makes sense. Why? You normally see it. I'll explain this in this video. What would happen if an airplane engine stopped working while it was flying? What did happen? And why would that happen? Anyway, thank you so much. Let's go. Let's continue the lesson. So I based the lesson to just 3 objectives, which is what forces act on an airplane during the flights? How do airplane wings help the airplane to stay in the air, and how the Bernoulli principle explains this? This is what we are going to do. Now, before the lesson, we'll watch 3 minutes video on this, then
So what actually keeps an airplane in the air? Why do passenger jets fly so high? Why are engines mounted under the wings on some aircraft and in the tail on others? Why is fuel stored in the wings? And why don't those wings snap even though they visibly bend in turbulence? Today, we're breaking all of that down. And after this, you probably won't look at airplanes the same way again. First, what actually keeps an airplane in the air? Have you ever wondered how something weighing hundreds of tons can not only take off, but fly across oceans for hours? At first glance, it feels like it shouldn't be possible. Metal is supposed to fall, but airplanes don't fall, they fly. And the reason comes down to 4 forces acting at the same time: weight, lift, thrust, and drag. Weight is gravity pulling the aircraft down. Drag is the air resisting its motion forward. Thrust is produced by the engines, pushing the aircraft ahead. And lift, created by the wings, is what keeps it in the air. When lift balances weight and thrust balances drag, the aircraft can fly steadily. But where does lift actually come from? Aircraft wings are not flat. They have a carefully designed shape and are angled slightly into the airflow. As the plane moves forward, air flows over and under the wing. Above the wing, the air pressure becomes lower. Below the wing, the pressure is higher. That pressure difference creates an upward force, lift. But that's only part of the story. The wing also deflects air downward. As airflow passes around the wing, it changes direction. And according to Newton's third law, every action has an equal and opposite reaction. If the wing pushes air down, the air pushes the wing up. So lift can be understood in 2 ways at once, as a pressure difference and as a reaction to air being deflected downward. That's what allows an airplane to stay in the air. And here's something many people get wrong. Engines don't lift the airplane, they push it forward. That forward motion is what allows the wings to generate lift. That's why, before takeoff, the aircraft accelerates down the runway. The faster it moves, the more air flows over the wings, and the more lift is produced. At a certain speed, with the right angle, lift becomes strong enough to overcome weight, and the airplane leaves the ground. That's how even something as massive as an Airbus A380, weighing up to 575 tons, can fly. It's not about weight, it's about how much lift the wings can generate at speed. But there's another important detail. At low speeds, wings are less efficient. So during takeoff and landing, airplanes use flaps and slats. These extend the wing, increasing its curvature and surface area, allowing it to generate more lift at lower speeds. If you've ever watched a wing during takeoff, you've probably seen it expand. That's exactly what's happening. Once the aircraft reaches cruising speed, those elements retract, because in cruise, efficiency matters more than maximum lift. In the end, flight isn't magic, it's balance. Wings generate lift, engines provide thrust, aerodynamics reduces drag, and all of these forces are constantly working together. Airplanes don't fly in spite of physics. They fly because engineers have learned how to use physics incredibly well.
What we learned from the video, we know that there are 4 forces that act on it. The first one from acceleration of mass, the lift force, the thrust, the weight, and the drag. Those are the forces that act on the airplane. Now, when these forces act, why does airplane lift from the ground? The airplane wings are shaped so that the air moves faster. The wings are shaped so that the air moves faster over it, and that creates a lower and higher pressure. This creates a lower pressure above and then higher pressure below. So we are going to look at this. So why does airplane lift from the ground? We say because the air moves faster. The wings are designed by a man called George Taylor. Designed the wings so that the wind moves faster at the top and it created a low pressure. It's like a building. When wind blows, it takes off the roof of a building. It does not take off the foundation. Why? Because it moves faster at the top than at the down. At the down, there are a lot of trees, cars, lots of objects, human beings are there that give a lower pressure. At the top of the building, at the top or in the air, there is lower pressure. Is there? The wind blows very fast at the top than at the down. So in the building, it take off in a whole building, take off the roof. Observe that. Now, means that in science, it's a very strong. When you move faster at the top, what happens? The pressure there is very low. There's low pressure there, but down that there are obstacles that are obstructing its movement. The pressure there is low. There are differences in pressure. Now, as we said, there's a man, George Taylor. I've said it. George Taylor is the brain behind. He discovered the wing shape. He designed the wing shape based on this the physical idea, the physics idea of movement of pressure differences. Now, who is this man? There's a man called Bernoulli, Bernoulli, Swiss mathematician. What did they do? Look at his principle in physics. Bernoulli explained that air moves faster. Air moves faster. If pressure becomes, when air moves faster, the pressure becomes very lower. As I've said, the story in a building, it normally takes to the top. The pressure, the wind or the wind blowing at the top the speed is higher than wind blowing at the down. Why? That's why building, the roof are normally take off than the bottom. That's why when air wind is blowing, it's blue, you bow down, you stay low to avoid the fast moving contact of the wind. So Bernoulli principle explained that when air moves faster, the pressure are the lower. The move faster, the pressure is lower. When it moves slower, the pressure is high. That's why look at it. The air moves about the differences in the speed of wind. So we have this in the wind. This is what we know. It generates a lift. The lift is generated. So there are differences in pressure here. So the top here, the lift is generated based on the top, because the wind moves very fast. There is low pressure here. This is for the higher pressure because the wind at the bottom is very low. So what happened? Differences in pressure enable the plane to take a step, move like this, straight. So this is the picture showing direction of the wind, how the wind flow. This is the airfoil here. You can observe here the differences in wind, lower and higher pressure. I give more explanation. This is the direction of the wind, higher and lower. According to Bernoulli example, Bernoulli fluid and the airplane design in this way. The wind moves here very faster, and down you can see the angle 20 degrees. It can be twisted an angle to generate a lift. If it maintains the same angle, the same speed, what happens? There is excuse me. Isaac Newton explained another part of the flight. He said, for every action there's an equal and opposite reaction. The wind designed to deflect air downwards. They designed the wind so that the air moves downwards. As the air pushes, so the air reaction by pushing the wind upwards. So this is still about the Newton's third law explanation. This is every reaction give equal opposite reaction. If you move faster, you go faster. This is how it is. In conclusion, you can say gravity move downwards, lift it upwards, thrust move it forward. The drag resists the motion itself as a brake, and the wind design, the airflow generate a lift. Newton's law explains this. Thank you so much. So this is a summary of what we were saying. Causing an equal opposite reaction, Newton's law of motion explains that by combining aerodynamic design, airflow management, engineering principle, enough lift to overcome gravity. So in conclusion, thank you so much for watching. Keep watching Relative STEM. This is what we do to bring STEM to you to explain scientific concept for you.